So as you've heard from the speakers before me, motor function, while not a core feature of the diagnostic criteria for autism, is highly prevalent, and there's been a lot of interest in motor function in this disorder. So difficulties that have been described by parents and carers and in the research have been reduced coordination, general awkwardness, but these difficulties and these differences between children with autism and typically developing children are sometimes subtle and difficult to depict accurately, and therefore difficult to target in interventions. So by using a kinematic analysis of movement, we require the use of specialised equipment to examine the timing, velocity, acceleration and spatial characteristics of motion. And so this type of analysis enables higher level examination of movement dysfunction and can help us to define the subtle movement differences. And from this information, we can generate inferences as to underlying disordered processes. So the first aim of this current study, which is part of a larger study looking at movement, was to examine upper limb motor kinematics in autism in a young cohort of children aged 3 to 7. So upper limb function in autism has demonstrated differences from controls, including the reach to grasp movement, gestural communication, and in handwriting. Previous studies have found that older children and adults with autism can take longer than controls to prepare movements in single-step, point-to-point movement paradigms. So this indicates a deficit in the preparation stage of movement. Few difficulties have been found in the actual execution of this type of movement, so in the single-step, point-to-point movement paradigm. To better understand this deficit, we wanted to know how early in development these difficulties in movement preparation might present. It was hypothesised that by using a single-step point-to-point movement paradigm, we might also find movement preparation difficulties in this younger sample. In addition, different types of upper limb movement, for example movements made up of multiple steps or those with an additional grasping element, appear to elicit further differences in movement kinematics. In a recent study by Fabri Destro and colleagues, it was found that controlled children adjusted the first step of a multiple step movement when the complexity of the final step was increased. Whereas children with autism did not adjust their initial movement to account for the increased complexity of the final step. So we looked at endpoint complexity using the single step point-to-point movement paradigm again with a visual distractor at the end target, so to change the endpoint. It was anticipated that children with autism would not change their movement on the basis of this visual endpoint distractor, whereas controls would make adjustments to accommodate for this changed endpoint. So 11 children with autism, with high-functioning autism, participated in this study and were aged 3 to 7 years. And these children were age, gender and performance IQ matched to typically developing controls. So in the single-step point-to-point movement paradigm, participants used a pen-shaped stylus to move between the start point and a left or right-sided target on a vertically positioned touchscreen, so as you can see from the top picture up there. We found that children with autism demonstrated more variability in their movement preparation time than control children. No other differences were noted in movement execution, including the time of movement or the velocities and accelerations of movement. In the visual endpoint distractor task, participants moved to a central target that was either presented alone or flanked by a left or right-sided distractor. So as you can see from the picture there, that's a picture of what the stimuli would look like for a right-sided distractor at the endpoint. We found that control children significantly adjusted their movement when the distractor was present, relative to the no distractor condition. So control children took longer to prepare and execute their movements and demonstrated lower peaks in velocity and acceleration. The children with autism, however, did not adjust their movement preparation or execution in the presence of a distractor, except to increase the variability in the time from peak acceleration to movement completion. So that just indicated that they adjusted the movement at the very late stages of movement, but did not take into account the changed endpoint when planning and preparing their movement initially.
2 minutes, please.
So finally, with respect to the single movement task, it is evident that a deficit in movement preparation in autism is apparent from an early age. So this is consistent with the literature looking at single point-to-point movement tasks and suggests that movement preparation difficulties may present early in development and be ongoing for individuals with autism. Investigation into the basis of movement preparation difficulties may in future provide a possible focus for early interventions. The absence of adjustment of movement in the presence of a visual distractor in children with autism, we thought suggested a deficit in global processing may impact on movement planning and execution in autism. So this preference for local processing, or the idea of weak central coherence, which has been highlighted as being important to other features of autism, may also contribute to the deficits that are observed in movement in autism. We thought that future directions may include more longitudinal kinematic analysis of motor function in autism and the use of contextual motor paradigms to establish an understanding of the developmental motor trajectory in autism. Thank you.
Thank you.